Let us now take the third model from this topic, where we shall discuss questions based on conditional permutations. That is, here questions are given based on permutations along with a certain condition that has to be followed. These questions are quite different from what we have done in Model 1. Model 1 was based on simple permutations or direct permutations where no condition is given. But here a condition has to be satisfied and the number of arrangements have to be done. Let us have a look at the first example. The question here is, how many different words can be formed using the letters of the word education such that the word always starts with the letter D? And as you can see here, such that the word always starts with the letter D is the condition. But because up to this point it is a simple question. How many different words can be formed using the letters of the word education? So that's a direct question. We know that there are 9 letters here, so 9 factorial should be the answer. But there is a condition which says the word always starts with the letter D. So here we need to find out only those words which start with the letter D. So how many such words can be formed? Now in general we know that here we have got 9 letters, E, D, U, C, A, T, I, O, N, and we have got 9 positions for these 9 letters. So we can say that without any condition the answer has to be 9 factorial. Why? Because 9 letters can be arranged in 9 positions in 9 factorial ways, and there is no repetition here. Each letter appears only once. So the direct answer is 9 factorial. But then the condition here says the word should always start with the letter D. So let's see how to solve this question with a given condition. Now as it says, the word always has to start with the letter D. That means the first position should always be occupied by the letter D. In general, without any condition, we say that first position can be filled in 9 different ways. But because any of these 9 letters can come there. But as the condition says the word should start with the letter D, here we have no choice. That is, the first position should always be occupied by the letter D. That means it can be filled only in one way. There is no other choice. There is no other option. Only D has to come there. So we cannot do anything with respect to the first position. It has to be occupied by the letter D. So there is only one way in which the first position can be occupied. And then the remaining 8 letters can be arranged in any of the remaining 8 positions. And that can be done in 8 factorial ways. So we can say that the remaining 8 positions can be filled in 8 factorial ways. So altogether the answer for this question should be 1 into 8 factorial. That is nothing but 8 factorial. But because one action can be done in one way, the other action here can be done in 8 factorial ways. So both together can be done in 1 into 8 factorial ways. So that's a simple way of solving this question. As the condition says, the word should start with the letter D. So let us fix D for the first position. And that can be done only in one way because we have only one D in the given word. And remaining 8 letters can be arranged in any manner. Why? Because the condition is with respect to only the first position. So we need not worry about the remaining 8 positions. And that we know can be done in 8 factorial ways. So that's why the answer is 8 factorial. Likewise, it can be any other letter in place of D. For example, let's say the condition says the word always starts with the letter U. Again, in that case, the answer will be 1 into 8 factorial. The only point is there, instead of D, we will be taking U in the first position. So that doesn't make any difference in the number of words formed. Answer still remains 8 factorial. So whatever be the particular letter, if it has to occupy the first position, that can be done only in one way. Remaining 8 positions can be filled in 8 factorial ways. And the other important point here is, it need not be always the starting letter. It can also be the ending letter. Let's say the question says, how many words can be formed such that the word always ends with the letter D. Even in this case, the last position is fixed. That is, it should be always occupied by D. So that can be filled only in one way. But remaining 8 positions, including the starting one, can be filled in 8 factorial ways. Why? Because there are 8 letters left out for the remaining 8 positions. So again, the point to be observed here is, it need not be only the starting position. It can be either the starting position or the ending position or any other position for that matter. So irrespective of the position, that is starting position or ending position or middle position or any other position, and also irrespective of a particular letter, that is, it can be E, D, U or any other letter, the answer for such questions should be only based on the remaining letters and remaining positions which have to be filled. A similar type of condition can also be given in case of persons. Let's say we have 5 boys and 4 girls who have to be arranged in a straight line. Now in general, 5 boys and 4 girls, total 9 persons can be arranged in 9 factorial ways. But let's say the condition says that the row should always start with a particular boy Amit. That means Amit should always be in the first position. So even in that case, Amit is fixed. That means first position can be filled only in one way. But remaining 8 positions can be occupied in any manner by the remaining 8 positions. So there again the answer will be 8 factorial. And in a similar manner, it can also be asked with respect to digits. For example, we have got 6 different digits and we need to form 6-digit numbers. In general, the answer is 6 factorial. But let's say the condition says the number should always start with 3. That means the first position should always be 3. So 3 is fixed in the first position. It can be occupied only in one way, and remaining 5 positions can be filled in 5 factorial ways. So the point to be noted here is, whatever be the type of object, it can be persons or it can be letters or it can be digits or any other object for that matter, the answer for these type of questions can be obtained by fixing the given position with the given object, and then the remaining positions have to be occupied by the remaining objects. Let us now discuss the second example from model 3, where again we shall discuss a conditional permutation, and here the condition is different from what we have done in example 1. The question says how many different words can be formed using the letters of the word education such that the word always ends with a vowel. As you can see, the condition says the word should always end with a vowel. We know that there are total 9 letters: E, D, U, C, A, T, I, O and N, and there are total 9 positions: 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these 9 letters have to be arranged in 9 positions. In general, without any condition, that can be done in 9 factorial ways. But here the condition says the word should always end with a vowel. That means the last position should always be occupied by a vowel. So first of all, let us find out how many vowels are there in the given word. Now here E is a vowel, U is a vowel, A is the third one, I and O are the vowels. So we see that there are all 5 vowels available in the given word: E, U, A, I, O. Now as the question says, the word should end with a vowel. Here the particular vowel has not been specified. It can be any of these 5 vowels. So we can say that the last position can be occupied by 5 different letters. It can be E or U or A or I or O. Any of these 5 letters can come here. Why? Because all these are the vowels which are available in the given word. So the last position can be filled in 5 ways. Any one of these vowels will come here, and the remaining 4 vowels will go for the remaining positions. Now remaining 4 vowels and 4 consonants, altogether we have got 8 letters for the remaining 8 positions. 8 letters can be filled in 8 positions in 8 factorial ways. That is a general permutation again. So very clearly the first 8 positions can be filled in 8 factorial ways, and the last position can be filled in 5 ways. And both together here can be done in 5 into 8 factorial ways. Why? Because this action we are able to do in 5 ways, and this action here in 8 factorial ways. So we can say that the answer is 5 into 8 factorial. Again here, it need not be the last position always. It can be any position which has to be occupied by a vowel. Let's say the question says the word always begins with a vowel. So there again, first position can be filled in 5 ways. Remaining 8 positions, including the last position, in 8 factorial ways. So answer still remains 5 into 8 factorial. And again, like vowels, the question can also be with respect to consonants. That means the first position should be occupied by a consonant. So we again find out the number of consonants, and those many choices are there for the given position. Remember friends, here the most commonly committed mistake is some students take it as 5 factorial for the last position. That is, because there are 5 vowels, they feel that last position can be filled in 5 factorial ways, and hence they say the answer is 5 factorial into 8 factorial, which is absolutely wrong. Why? Because last position can be filled in 5 ways, but not 5 factorial ways. There are 5 vowels available, any of these 5 can come. 5 factorial should be taken only when there are 5 objects and 5 positions. Here we have only 1 position for 5 objects. So that is the reason we take it as 5, but not 5 factorial. So don't take it as 5 factorial into 8 factorial. It should be 5 into 8 factorial. And like for letters, the similar condition can be asked for digits or for persons. For example, let's say we have 4 boys and 4 girls who have to be arranged in a straight line for a photograph. Now in how many ways can the arrangement be done such that the row always begins with a girl? Now like in the previous example we have seen, the row should always begin with a particular boy like Amit. So that is only one way to fill the first position. But here the question says the row should begin with a girl. So there are 4 girls, any of these 4 girls can come there. So first position can be filled in 4 ways, and remaining 7 positions can be filled in 7 factorial ways. And similarly it can be asked for digits as well. Let's say there are 6 digits, 1, 2, 3, 4, 5 and 6, and we need to form 6 digit numbers such that the first digit is always an even digit. So it can be 2 or 4 or 6. That means first position can be filled in 3 ways, and remaining 5 positions can be filled by the remaining 5 digits in any manner. So we can say the answer here is 3 into 5 factorial. Let us now take the third example from model 3, where we shall see a condition which is a combination of the conditions given in first 2 examples. Let's have a look at the question first. how many different words can be formed using the letters of the word education such that, now the condition says the word always begins with the letter A and ends with a consonant. So here as you can see, there are two conditions. The word should begin with the letter A and it should always end with a consonant. So very clearly it is a combination of the condition in example 1 and the condition in example 2. Now let's see how to solve such questions. Now simply, as we have discussed in the previous two examples, we need to just work on the two conditions and then the remaining arrangements can be done in a general manner. Now as it says, the word should always begin with the letter A. That means first position should always be occupied by the letter A. So we have no choice but to take A in the first position. That is, the first position can be filled only in one way. So we can say first position should always be occupied by A. So there is only one choice and the first position can be occupied in just one way. And the next condition here says it should end with a consonant. Now here in the given word we have got consonants D, C, T and N. These are the four consonants. So here last position can be filled either by D or C or T or N. That means there are four possible letters which can come in the last position. So we can say last position can be filled in four ways. Remember friends, four ways but not 4 factorial ways. Why? Because 4 factorial should be taken when there are 4 positions and 4 objects. Here we have 4 objects but only one position. So that is 4P1 or 4. So last position can be filled in 4 ways. So any one of these 4 consonants will come in the last position and the remaining 3 consonants will take any of the remaining 7 positions. So first position can be filled in one way, last position can be filled in 4 ways. And we have got 7 positions left out with 7 letters. And that can be done in a general manner in 7 factorial ways. So we can say the intermediate 7 positions here can be filled in 7 factorial ways. So here we have got 3 actions together. So we can say altogether the answer here will be 1 into 7 factorial into 4. That is nothing but 7 factorial into 4. So from this example and the previous 2 examples, we can very clearly understand that for solving questions based on conditions, we first need to work on the conditions and then the remaining positions can be filled in a general manner. So always try to satisfy the conditions first as given in the question and then go for the remaining positions. Let us now take the next example from model 3 where we shall look at a new and a very interesting condition. The question here says how many different words can be formed using the letters of the word education such that the first bit says all the consonants are always together. And the second one here says the letters D, A, O and N are always together. So here we see that the condition is with respect to a set of objects being together. The first one says all the consonants must be together in whatever words we form. And the second one says these particular letters have to be together in whatever words that are formed using the letters of the word education. Now we know that there are total 9 letters, total number of words that can be formed here is 9 factorial. But there is a condition that the consonants are always together. So let's see how to solve such questions. Now here in the given word the consonants that we have are D, C, T and N. Now whenever we want a particular set of objects to be together, what we do is join all of them and consider it to be only one object. That is, here we don't count D, C, T, N as 4 letters. In fact, we'll take it as only one letter. And the remaining letters are E, U, A, I and O. So altogether we can say that there are 6 objects. 1, 2, 3, 4, 5 and 6. Now we know that 6 objects can be arranged in 6 factorial ways. Let's say there are 6 positions and these 6 objects can be arranged in 6 factorial ways. Now the point here is when we take D, C, T, N as only one object, it means wherever these move, they will always be together. And that is what is required, that the consonants must always be together. So if there are 6 objects, we can say total number of arrangements are 6 factorial. And at the same time, these 4 consonants internally can be again shifted. Why? Because the question only says that consonants have to be together, but order can be anything within the consonants. So here 4 consonants can be internally arranged in 4 factorial ways. Why? Because there are 4 positions and 4 consonants. So total number of arrangements are 6 factorial and internal arrangements of consonants are 4 factorial. So we can say that the answer here will be 6 factorial into 4 factorial. Let me repeat this once again. Whatever objects are to be together, we always join them and consider it to be only one unit. For example, here as you can see 4 consonants, that is considered as only one letter. Remaining 5 letters, total 6 letters can be arranged in 6 factorial. So by doing this, we make sure that these consonants are always together. Why? Because they are connected to each other. They are considered as only one letter. Once these arrangements of 6 units have been done or 6 letters have been done, internal arrangements of the consonants can be done. Why? Because consonants must be together. They can be in any order. So that will give us 4 factorial. So total arrangements are 6 factorial into 4 factorial. Likewise, if the question says vowels have to be together, we can say that all the vowels are only one letter. So 5 vowels joined together will give us 1 letter. Remaining consonants can be arranged together, and then internal arrangements of vowels can be done to get the required answer. Similarly, the second question says how many different words can be formed using the letters of the word education such that the letters D, A, O and N are always together. Now here particular letters have been specified. It is not like vowels have to be together or consonants have to be together. Some set of letters have been given which have to be together. So what do we do? Again join all of them. D, A, O, N is only one letter. These are not 4 different letters. It's only one letter. Remaining letters are E, U, C, T and I. So we find that D, A, O, N have come together as the first letter. Then remaining are E, U, C, T and I. So these are the total number of letters. 1, 2, 3, 4, 5 and 6. 6 letters can be arranged in 6 factorial ways. Internally, these 4 letters can be arranged in 4 factorial ways. So again we say that answer is 6 factorial into 4 factorial. Likewise, the same concept can be applied for persons or for digits. Let's say we have to arrange 4 boys and 4 girls in a row. Now total 8 persons can be arranged in 8 factorial, but the condition says all the boys have to be together. So there the 4 boys are joined together. We consider them as only one person. Now one person and remaining 4 girls, altogether we have 5 persons. 5 persons can be arranged in 5 factorial ways. Internally the boys can be arranged in 4 factorial ways. So in that case the answer will be 5 factorial into 4 factorial. Or otherwise the question can be asked in terms of digits. We have got certain number of digits. Let's say we have 6 digits, 1, 2, 3, 4, 5 and 6, and we are supposed to make 6 digit numbers out of it. But the condition is all the odd digits have to be together. That means 1, 3 and 5 must be together. So again we join them, do the total arrangements and then internal arrangement. So whatever be the type of object there, whenever we want certain number of objects to be together, first join all the objects, consider it as only one object. Then do the total number of arrangements and then proceed for internal arrangements. Let us now look at the next example from model 3, which again is a new condition. The question says how many different words can be formed using the letters of the word education such that first bit says no 2 consonants are together and the second one says the letters A and T are never together. So as you can see, this is quite opposite to what we had done in question number 4. There it was all the consonants have to be together, and here it says no 2 consonants are together. That means consonants must never be together. Let's see how to work on this one. Now we know that there are total 9 letters, total number of words that can be formed will be 9 factorial, but the condition is no 2 consonants are together. Now whenever we want a set of objects not to be together, we first arrange the remaining objects. For example, in the first question here it says the consonants should not be together. No 2 consonants must be together. So we will first try to arrange the vowels. We know that there are 5 vowels here, E, U, A, I and O. So 5 vowels E, U, A, I and O can be arranged in 5 factorial ways. So they can be arranged in 5 factorial ways. That means there are 5 vowels and 5 positions, let us say. So they can come in any of these 5 positions, and total arrangement that we get with respect to vowels only is 5 factorial. And now we need to arrange the consonants in such a way that the consonants are never together. No 2 consonants are together. So we have to find out the possible places where the consonants can be placed. Now the number of positions where the consonants can be placed are as follows. We can have consonants in this position, here, in between U and A, in between A and I, in between I and O, and after U. That means we see that there are 6 positions, 1, 2, 3, 4, 5 and 6. So these are the 6 positions where if we put the consonants in any of these 6 positions, we find at least one vowel coming in between them. Let's say we have placed the 4 consonants D, C, T and N in the first 4 positions. So if we consider the first 4 positions, we see that E, U and A has come between the consonants. So they are not together. Likewise, if we take the first, second, fourth and sixth position. So if we take first, second, fourth and sixth position, we find that in between first and second positions there is a consonant, there is a vowel E. So these 2 consonants are not together. Then if we take fourth and sixth positions, we find that between 4 and 6, between these 2 positions, there are 2 vowels, I and O. So again, the 2 consonants that we have kept here are not together. And also there is a vowel between the consonant at second position and consonant at fourth position. Why? Because U and A will come together there. So the simple idea here is we first need to arrange the vowels and then find out all those possible positions where the consonants can be placed such that they are never together. So here we find that vowels can be arranged in 5 factorial ways, and after that we have got 6 possible positions for the given consonants. Out of these 6 positions, we need to take 4 of them and arrange the 4 consonants on that. So that's like total 6 objects we have, or total 6 positions we have. Out of that, we need to arrange 4 of them at a time. So we can say that the consonants arrangement can be done in 6p 4 ways. So the answer for this question here is 5 factorial into 6p4. Let me repeat it once again. Whenever we want the consonants not to be together or any set of objects not to be together, we first arrange the remaining objects. So here the remaining objects are nothing but vowels, which can be arranged in 5 factorial ways. After that, we count all the possible places in which the consonants can be placed. It can be between the vowels and at the extremes. So total there are 6 positions. So in the 6 positions, we can take any 4 positions and arrange the consonants in those 4 positions, and we find that they are never together. Remember friends, when we arrange the consonants in first 4 positions, let's say we have arranged the 4 consonants in first 4 positions. In that case, the 5th and 6th positions are removed. That is like they are not existing there. So I and O will come together. It doesn't mean that 5th position is vacant. It's not like that. These are the possible positions where consonants can be placed. Likewise, when we take 1st, 2nd, 4th and 6th position, let's say, then the 3rd position and 5th position will not lie vacant. They are automatically removed and letters come together. So don't misunderstand that after taking 4 positions out of these 6 positions, any 2 are left out. It's not left out. Only point is those 2 positions get removed and the letters there come together. So this is how we can do the arrangements when we want a set of objects not to be together. Likewise, it can be asked for boys and girls or for digits. Let's say we have 6 digits and we have to form 6-digit numbers. The digits are 1, 2, 3, 4, 5 and 6. And the question says no 2 odd digits have to be together. So we first arrange the even digits and then find out the possible places and arrange the odd digits within them. Likewise, it can be for boys and girls or men and women. Let's say we have 5 men and 6 women. Altogether we have 11 persons. 11 persons can be arranged in 11 factorial ways. But the question says no 2 men have to be together. So we first arrange the women. Then we find out all the possible positions in which the men can be placed. Then arrange the men in those places to get the required answer. Let's now look at the second one here. The letters A and T are never together. So this is again similar to bit number 1. Here, these 2 letters A and T are not to be together in any word that is formed. So we first arrange the remaining letters. So leaving A and T in the given word, if A and T are left out, the remaining letters are E, D, U, C, I, O, N. So E, D, U, C, I, O, N. These are 7 letters and they can be arranged in 7 factorial ways in 7 positions. So we get 7 factorial arrangements. Now after arranging these 7 letters in 7 factorial ways, we have to now find out those positions in which the 2 letters A and T can be placed. Now we find that the positions here are in between positions and the extreme positions. So 1, 2, 3, 4, 5, 6, 7 and 8. So these are the 8 positions in which we can place the letters A and T. You take any 2 positions, we find that in between them at least one of the remaining letters will come. So that means they are never together. So out of these 8 positions, we need to select 2 and arrange the 2 letters in those 2 positions. So that's like total we have got 8 objects. We need to arrange 2 of them at a time. So that can be done in 8p2 ways. So we can say it is 7 factorial into 8p2. That's the answer for this particular question. So this is the difference between example number 4 and example 5. In example 5, when we want certain objects to be together, we join them and consider it as one unit. Do the total arrangements and then internal arrangements. And in example 5, that is when we want objects not to be together, we first arrange the remaining objects, find the possible positions and then place these objects in the given positions.